Have you ever wondered what makes a light bulb glow or a fan spin? The answer is electric current. Electric current is the flow of tiny particles called electrons. Think of it like water flowing through a pipe. The water represents the electrons, and the pipe is like the wire. Just like how water flows from a higher point to a lower point, electrons flow from a point of higher potential to a point of lower potential. This flow of electrons is what we call electric current. Electric current is measured in a unit called amperes, often shortened to amps. A higher amperage means more electrons are flowing per second. We use a device called an ammeter to measure electric current. Understanding electric current is important because it powers so many things in our lives. From the smallest gadgets to the largest machines, almost everything we use relies on electricity in some way. An electric circuit is like a pathway for electricity to flow. It's a closed loop that allows electrons to travel from a power source through various components and back to the source. Think of it like a racetrack for electrons. The basic components of an electric circuit include a power source, wires, a switch, and a load. The power source, like a battery or a power outlet, provides the energy that pushes the electrons through the circuit. The wires act as the track itself, guiding the electrons along the path. The switch acts as a gatekeeper, controlling the flow of electrons. When the switch is closed, the circuit is complete and the electrons can flow. When the switch is open, the circuit is broken and the electrons cannot flow. The load is the part of the circuit that uses the electrical energy. This could be a light bulb, a motor, or any other electrical device. Understanding how these components work together is essential to understanding how electric circuits function. Electric current flows through a circuit much like water flows through a pipe. The power source, like a battery, creates a difference in electrical potential, which pushes the electrons along the wires. Think of the battery as a pump that pushes the water through the pipes. This difference in potential is what causes the electrons to flow from the negative terminal of the battery to the positive terminal. The wires provide a path for the electrons to travel, just like pipes provide a path for water. As the electrons flow through the circuit, they pass through the various components, such as the switch and the load. The switch controls the flow of electrons, either allowing them to pass through or blocking their path. Once the electrons pass through the load, they continue their journey back to the positive terminal of the battery, completing the circuit. Section 4. Effects of electric current. Electric current has several effects that we can observe and utilize in various applications. One of the most common effects is heating. When electric current flows through a conductor, it generates heat. This is the principle behind electric heaters, toasters, and even incandescent light bulbs. Another effect of electric current is the magnetic effect. When electric current flows through a wire, it creates a magnetic field around the wire. This is the principle behind electromagnets, which are used in devices like electric motors, generators, and loudspeakers. Electric current can also cause chemical effects. This is the principle behind electrolysis, which is used in processes like electroplating and battery charging. Finally, electric current can also produce light, as seen in LEDs and fluorescent lamps. Section 5. Applications of electric current. Electric current is used in countless devices and applications that we encounter every day. Our homes are filled with devices that rely on electric current, such as lights, fans, refrigerators, televisions, and computers. Electric current is also essential for transportation. Electric trains and subways rely on electric current to power their motors. Electric cars are becoming increasingly popular, offering a cleaner and more sustainable mode of transportation. Industries rely heavily on electric current for powering machinery and equipment. Factories use electric motors to drive assembly lines, power tools, and operate other machinery. Communication systems also depend on electric current. Telephones, radios, and televisions all use electric current to transmit and receive signals. Section 6. The importance of understanding electric current. Understanding electric current is crucial for navigating our modern world. It helps us appreciate the technology that surrounds us and empowers us to use it safely and effectively. Knowing how electric circuits work allows us to troubleshoot simple electrical problems in our homes. Understanding electric current also fosters a deeper appreciation for the role of electricity in our lives. Furthermore, understanding electric current opens doors to exciting career opportunities. Electrical engineers, electricians, and technicians are just a few examples of professions that require a strong understanding of electric current. By understanding the importance of electric current, we can contribute to a brighter and more sustainable future for generations to come.